I don't work for Google. I don't work for Microsoft. I don't work for Amazon. I don't work at any of the places you would think you'd need to work to do kind of deep JavaScript infrastructure. And I never have. I've never built anything that would make you think that I should be tackling a JavaScript runtime. In fact, the most commercially successful software I've ever written was Rails, which is the opposite of a JavaScript runtime. Which makes me wonder, and maybe makes you wonder, but if you're too nice to say it, why I'm up here talking about this. So that's what we're going to talk about. The answer is a couple years ago, a friend and I decided we needed to find something to work on. We didn't like our jobs. We didn't like the company we were working for. We wanted to work on something that we could make good. And we decided to build a CDN, which is something that had been irritating us for a long time. So while I don't work at Google and Microsoft and Amazon, and I've only ever worked on Rails, I also get really mad when tools that I am using don't do what I want. And so 22 months ago, I think that's exactly right. It was the CDN. It's like CDNs are kind of hot garbage. They're the same thing they've been for the last 15 years. They don't really solve problems that I have as a developer. They tend to solve problems that other people have that don't make any sense to me. And so we decided, hey, let's make a CDN for developers. Let's actually solve this problem. And you'll notice I'm not talking about a runtime yet. So over the next 22 months is kind of how we got to what we're talking about today. So when you decide to make a CDN, the very first thing you start thinking about is you usually want a proxy server of some kind and some level of caching. And anyone who's ever used Nginx knows it's crazy fast, it's crazy reliable. It's that category of infrastructure that you just use, you don't modify, because it's so good that the friction it takes to make it do what you want is high if it's not already. Nginx lets you script it with Lua. So what we did is we sat down and we started trying to build features for our mythical programmer-friendly CDN in Lua, which was okay, except Lua and Nginx have a terrible programming model. You basically write a giant config file and you inline your Lua with it. You hook into certain events during the request. It's not a fun thing to build. So 2 months later, we wrote our own proxy from scratch in Go, which is delightful. Go is an amazing way to build network services. We were very productive. We were able to ship a lot of features. We gave people a really cool web UI for, hey, this is all the different things you can do with our proxy that we've now built for ourselves that you can't see the code for, but you can just trust it works really well. And we immediately got like hundreds of feature requests. And these aren't, anytime you build something from scratch, you're going to get a lot of feature requests. You're going to get a lot of things that you just shouldn't do for people. Like really the answer to a lot of feature requests is no. But this time what happened is we got a lot of feature requests, a lot of different use cases we were hearing, and they were all legit. And what ended up happening, I think, is as we were talking to our customers about this stuff, we sort of realized that they were asking for a different level of product than what we were providing. Basically, our customers were asking us for the ability to implement their own logic. It wasn't a thing we could solve with a UI. It was a thing that we could solve by basically giving them a programming language. So it's like, cool, we have this cool Go proxy. It does what we want, and we want to let people modify it for their own purposes. And so the very first thing we did with our Go proxy when we wanted to make it more powerful for people is we started looking at Go-based JavaScript runtimes. If you haven't heard of these, Otto is the one we looked at really close. There's one called Goja. And what these are is they're basically clean implementations of JavaScript in Go. They're relatively safe. They're not doing low-level memory management. You're kind of immune to a lot of the security problems you'd have by letting people run code usually. So it seemed like a good thing to start with. Problem is, JavaScript is really slow, like really slow. It's actually ridiculously slow. And we all use JavaScript, and it's not a thing we think all the time, but it's actually pretty terrible. If you look at what JavaScript's doing when it adds two numbers together, this is the series of instructions. Like, reading this takes 30 seconds. It's just not a simple thing that basically running JavaScript code. It's very complicated. And so basically, there was no way we were going to give people anything valuable by using JavaScript in this way. Fortunately, V8 exists, and V8's very fast, and Chakra's fast, and SpiderMonkey's fast. Basically, the big companies I don't work for that do build infrastructure have built JavaScript engines that solve a lot of these problems. And it's actually kind of fascinating how they solve the slow JavaScript problem. Here's what V8 does when it runs your code. This is the whole step. And there's one very, very important thing here, which code generation. What V8 actually does as you run your JavaScript, as it's optimizing it, is it rewrites it in not JavaScript to make it fast. So it's actually, again, we're at a level of thing here that I don't think we can build. So V8, very cool, does a lot of stuff, needs serious computer science people. Why don't we see if we can take advantage of this? Next step was V8 in Go, which is an awful idea. It's just don't do it. Basically what happens is Go has opinions about how programs should work. V8 has opinions about how opinions should work or programs should work. They don't match. It's kind of a disaster to try and run. So a year and 2 months later, we finally said, hey, let's just run V8 in Node, which is really odd if you know anything about Node. Node is V8 plus IO libraries plus some other stuff. We found a cool package called isolated VM. And what isolated VM does is it lets you use Node, use JavaScript in Node to create new V8 isolates. And a V8 isolate is basically the virtual machine that runs JavaScript in V8. And what was really cool about this, and in our project origin mythology story, when I retell this in 5 years, it's gonna be like, yeah, we decided to prototype this in Node with V8 because it was just the smart choice. But by accident, it really was. Node is a really nice place to prototype JavaScript runtimes because you have all of this stuff there. Node already controls V8. It's pretty easy to hook into it and create new isolates, run your own code. So I would highly, highly recommend you all trying this out if you have any desire to build your own JavaScript API at some point. It's very confusing for users, but it works well. Problem with V8 and the problem with every JavaScript engine is they don't do anything. So like the fetch function that we'd use in the browser is really handy. It's the way we make HP requests, get data from the internet, which is kind of the core of almost every program. So when you try and run fetch directly in V8, it'll just say, hey, I can't run this, I don't know what fetch is. When you try and run console.log, here's the API. So what you end up doing is you have to implement the fetch API from scratch, which is a big, hairy beast, but at least it's accessible. It's a nice API. But you end up, what Node let us do is get straight to V8 and start prototyping what we wanted our JavaScript environment to look like for users. Console.log also does not work. All the plumbing's there in V8, but if you run console.log, nothing happens. And the way you can think about V8 JavaScript when you put JavaScript into V8 to run it is it's a black box. It doesn't affect the outside world at all. It just does some stuff in memory, and then it tells you it's finished, and hopefully you're happy with that. You can't require things. There's no module support. You have to implement this stuff from scratch. Or you can take the shortcut we took for our prototype and use Webpack or something like that to bundle files and just give it one big old JavaScript. But ultimately, we were able to build a set of libraries within V8 that let people fork the CDN. And what I finally realized, way too late, like again, startup origin story, I'm going to say this was our dream all along, and we started at the beginning, and ultimately we got there, is that if we're building something for developers, it needs to fit how developers work. And I guess forking things is kind of the lowest level way to tell if you're doing what developers want to do. Developers want to write code. They want to fork what's already there. They want to modify it. They want to write unit tests. They want to do continuous integration. They want to do all of these things that you wouldn't necessarily be able to do in something like our UI that I really liked but wasn't really useful for them. So that was cool. We gave developers a way to do this. We gave them an open source runtime they could run locally. Got a lot of traffic. And then they started building these really cool things. This is just a block of code, and what this is doing is someone has basically made our CDN watermark their images. If the image is on their site, there's no watermark. If it's linked to a third-party site, they suddenly get their logo watermarked on it, which just blew my mind. I think it was one of the happiest things I've ever felt is seeing someone take something we built and then do something with it that I just never even thought of. It's way beyond our imagination. It's one of the more rewarding things about actually getting to this level of what you're shipping to people. And there's a lot of other things people have done with it, and our traffic blew up, and we started having problems, and then we ran into node issues. This is a graph of our event loop lag, and if you've really ever used Node in anger, you've probably been irritated by the event loop at some point. What's happening here is, and just as a summary, what happens to the event loop is if someone wants to use a fetch function, what they do is they call our native code. The native code goes out and does its thing, and then it puts a message back on the event loop to be consumed later. And so what we're tracking here is how long after something gets on the event loop does it take for it to be available to the code that uses it. And you'll see it's very variable. It's spiking very high. It hovers around 2 milliseconds, which is really not that great in the best cases. And so what's happened now is we've been successful enough with what we're now calling our prototype that we actually need to make this scale and perform consistently so we can do other stuff. Because once you get beyond HTTP, when you start talking about like terminating SSL connections or doing any of the other things that a CDN needs to do, this type of performance is just going to be a pain. So now we're in hard mode. So the next step after our node prototype is to basically, we built in Rust, excuse me, and actually we built a lot of this in Rust and extracted some things from Deno, which if you haven't seen Deno is Ryan Dahl's new JavaScript runtime that he's trying to fix some of the problems he felt like Node had. So we started using Rust to create these V8s and manage them because we needed much more control over things like the event loop. We needed a lot more than Node was delivering. And Rust is really nice, and if you haven't used it, it's incredibly performant, has a very strong type system, and if you haven't used something with a strong type system, it takes a tremendous amount of work to like start figuring out how to use it and how to get the most out of it. But once you get there, you can build something like this, which is an example of a customer application we have that is actually responding to DNS queries. And DNS is one of the most latency-sensitive things that happens within the context of a CDN. So the fact that we've gotten to someone, we can accept a DNS request, we can get it into user code in far less than a millisecond, and then they can respond to the DNS query, means that we're doing a pretty okay job with performance at this point. But like I said, it's hard mode. Rust is very, very difficult and very, very rewarding if you've never used it. So we built a runtime. Like I said, I'm not the person that you would have expected to do this thing. And one of the big realizations I had with all of this was that most of what was preventing me from tackling something like this, it was all a mental block. We're all lucky enough to work in this stack of technologies where we can change every little bit of it. We're not like trying to modify a car here where we can't actually go change how the brake system works. We're building something where we actually have the ability to go in and make changes that we want to every layer of everything that's happening between us and our users. And the other really fascinating thing for me as we've done this has been to just compare the complexity of what I'm talking about with like just the general complexity of a front-end stack. So basically everything I just talked about is pretty complicated. There's a fair amount of things we had to learn, but it's actually, in my mind, it's simpler to put in your head and simpler to understand than your normal React application is. There's so many moving parts in front end. Like we're all kind of used to this level of complexity. I think that the trick for every one of us is to expand our minds a little bit and get beyond the Rails or the React or whatever and actually start making these tools do what we want. So not only did we build a runtime, but you can too. And because anyone can cook. So this is the end of my Ratatouille theme. But yeah, that's it. Everyone can cook JavaScript.